Indeed, 2 minutes late. I apologise. I was trying to get the kids into bed. Connor, Mr. Steak? I don't actually know how to pronounce that. I apologise. Or Mrs. Take. KK, Moose, Arand, Connor, hello. Daz, Matthias, Mr. Steak, yeah. Got it, nailed it. Dort, hello. Oh. Indeed, interesting. Okay, fine. Ugh. Moose, hope it's going okay. So to get swap page. Get a big hard drive. Param, hello. Okay. What do I want to do today? I want to expand on what we did last time. So we need to add a keyboard controller for the camera. We then need to start adding model-specific information into the kind of pipeline. So a transform matrix, for example. So a model matrix that gets up to the graphics card. And then I want to do some sort of material type system, so start pushing stuff into a buffer somewhere that's going to be needed for rendering. So I guess to start it'll just be color, but that'll eventually become image ID in bindless handles for albedo, whatever you want to call it, diffuse maps, sorry, not diffuse maps, specular maps, normal maps, that kind of thing. I kind of want to do emissive materials as well, so a whole bunch of stuff. We're going to need to kind of lay the framework for today, then we can slowly start building out. Julian, hello. ZZZ, YY, XXX. Okay, so let's just see what we got. It's always going to be ranges. Okay, so this is what we got at the moment. The camera, I think, moves. And then we control this with the mouse. We can't. The keys don't do anything at the moment. So what we want to do is get WASD working first, so we can move around the scene, and then we can start pulling some bits out into various new buffers and such. So we're going to have a little bit of indirection today because we have the vertex data, which is a buffer. We'll then need to have object data, which will be like the model matrix, and then that will then have an index probably into some material information, and then that will be various things like, you know, color and like I said, all the texture stuff. So we're probably going to pull color out of the vertex data today and basically push it somewhere else. Shuck, hello. Yes, thank you, Kale. I enjoyed that. Cho's a nice guy. I enjoyed sitting down talking with him. I'm hoping to do some more stuff with him, but I know he's just kind of started a new role, and his kind of stuff that he's on YouTube is, I think he's taken, you know, doing slightly less on YouTube, so we'll see. So let's go to the main. I think we've shoved everything in main these days. Yeah, so the camera just slowly pulls back. So this needs to go away, and then we need to add some sort of character controller. I've got some code for this somewhere else. I'll probably start cribbing from that. Let me try and get that up somewhere else. So you game, I think. Source. Oh, I can't remember what it was called. Maybe player. Yeah, here we go. So we have keys. Sorry, I'm bigging this a bit. So we'll basically keep track of the key state, and then we will update the camera walk direction based on that, and then we'll scale it based on some speed, and then we'll just translate the camera by that. So I think that's what we're going to do. I've no idea what this is. I'm going to assume it's a Boolean a map of keys to Booleans. So I guess probably just start there. I wish you luck. Consider luck wished. I know, unordered map. Oh. And then I guess outside the main loop, we'll have like a auto key state equals stood unordered map. UFPS key to a bool, and then the ones that we care about to start with will be UFPS key A, and that will be false. I'm just knocking this together super quick. I see. WASD. And then we can do. Do I even need that? Am I just gonna put in all the key states into this? I'm just gonna put all the key states into it actually. So else. I mean, I have no plans to integrate ray tracing made by myself or anyone else for this. Maybe in the future. Also, it would probably have to be Vulkan, I suspect, to really get the most out of ray tracing. So actually, all I probably want is key state arg.key equals arg.key state key. What's a key event? What's it called? Key state. Okay. Key state. It'll be true if it's pressed. So if equals UFPS key state down. I think that's what I need. That's a function. That might be state. Yeah. Okay. So now I should be able to just copy and paste this code. I might just stick this up in a function up here just to keep it out of the way. So auto walk direction constant unordered map. UFPS key state bool key state, and this will produce a UFS vector. So this is just going to handle the gubbins for that. So why not use an event dispatcher? Because we haven't built one yet. This is still really early days. I'm just kind of hacking in stuff that just gets us what we need to be doing. Like on the previous project, we kind of pulled out like a message bus system and an event system a bit later on. It's not really getting it. We will need to eventually, but it's not something that needs to be done now. So I'm kind of happy just to make it a little bit simpler, just so we can kind of be moving around and getting on with stuff. But it's a good question. Ordered map. Okay, fine. And then nope. So auto direction equals UFPS vector 3, and then return direction. Study. Okay, so now this will just give us the direction, and then we can just simply calculate this based on if key state UFPS key W, then direction plus equals. Oh, we're gonna need a camera in here, aren't we? Because then we just do this based on the camera. const UFPS camera, yeah. Camera plus equals camera dot direction. Key. Right, there we go. So the arrow syntax is just it's the trailing return type syntax in C++. It's just an alternative way of specifying that the return value is at the end. So you just do auto something returns this. It's just a personal preference. You don't have to use it. There is like one situation, I think, with templates where you do actually need it, but it's kind of a little bit niche. I just like it aesthetically. I normally do about 2 hours, give or take. So that's sort of roughly how long we're trying to go for today. That's a good point, because that will create this is not working because this is const, and this will create the value if it doesn't exist. I actually just don't actually care. I guess we could assume it will be there because we do. What's the 1,000 different ways of checking something's in a map? Try and build like a little FPS, but like a vertical slice of an FPS. So it won't be like a full game with like a story and plot and stuff like that. It's just the technical stuff that we need to do to kind of run around, shoot things, look half decent. I really actually can't be bothered with all this for simple code. I'm just gonna make that. I'm going to do that. Otherwise, I'd have to get like check it contains and get an iterator to it, and then check it, or get an iterator to it, check that's not null. It's a lot of typing. This is a lot easier. So then, you can, these need to all be ifs rather than else if, because we want to support if multiple character. Oh, there's a bug there. Plus equals. We want to support multiple keys being pressed at the same time. No, multiplayer is out of scope for this project, but maybe the next one. Maybe check back in 12 months' time. These projects, at least the last project, went on for about 12 months. So I'm kind of anticipating a similar length for this. So D will be direction plus equal camera dot right, and then if key state UFS key A direction minus equals camera dot right. It's already open source, yeah, you can check it. Thank you, Julian. So this will give us a combined vector based on all the character presses, but what this means at the moment is that if you basically press forward and right, you will move twice as fast because you accumulated both a forward and a perpendicular vector. So then we need to normalize it and then scale it based on the speed. So our final direction will be UFPS vector 3 normalize the direction times by, I don't know, some sort of velocity. So const expra auto velocity. What did I use for the last one? Like 0.5f. Oh, actually, technically it's a speed because it doesn't have a direction yet. Shut up, physics nerds. I don't want to switch because I want to make sure I can handle all of these if they're both if W and S are both pressed. That's a bit bad example. If W and D are both pressed, I want to handle both of those. Whereas a switch statement would just pick out one. You could iterate through all the key states and then switch on them, but then I think that's wasteful. This is just like, because it's state management, right? I need to check individually if these are checked. Yeah, so this is how we account for that, right? We normalize it. Okay, so now, Queco, bit late, but it's fine. Or have you been here the whole time? Yeah, no, it's fine. A good point. Okay, so now we should be able to just do camera translate the walk direction, key state, and then the camera, the single camera itself. It's a little bit messy, but this will go away eventually. This is not the thrust of today's work. This is something just to get us going. Ah, nice. I too had a similar weekend experience. That's nice. Okay, so we should be in. We're in the cube, right? So I should be able to back out now. Oh, that is fast. I guess because the cube is tiny, but you can kind of see. We should be able to like go under it, and so there's no lighting at the moment, but we can move around it. That's nice. That was nice and easy. Let's get us going with that. So let's add camera controller. Nice commit to get started with. Yeah, like basically, well, is VSync not enabled by default on OpenGL? Like, does it not cap it at your frame rate? I seem to remember you have to kind of opt out of that, but I could be wrong. Yeah, there's no lighting at the moment. We'll try and sprinkle some of that on today if we can, because we can just slap some normals in later. But for now, that'll do. I don't want to do too much on the lighting because we're going to do a deferred renderer later. So any lighting we add now, we will have to basically rip out. So I'm not too fussed about doing it now, but we probably should do some just to kind of satisfy ourselves the setup's right. Okay, so that was that. So now we want to do. So if we go to the renderer at the moment, we do projection times view. So we need to have in here some, like, it won't be exactly this, but it'll be something like this, right? So each entity that we are rendering must know its place in the world. Very philosophical. And we need to draw that out from somewhere. So I'll probably have some sort of object data struct. So let's do struct, I don't know, object data. And then this can have a map for model matrix. Okay, so that's probably the first thing we need to do. And there will be as many of these as there are objects. So because we're using MDI, multi-draw indirect, we should be able to use the GL something or other, draw ID, I think. Look at my notes, which is the unique ID given to each draw command, and then we can use that as an index into the array, basically. Yeah, I think that I would probably need to spend a bit of time like thinking about what that actually means and what I want to do. It's not something I'm going to kind of do today. For the moment, the defaults are just fine because we're just rendering cubes and stuff like that. But yeah, there's some thought I need to give on that. What that actually means is I need to harass Harand on Discord about it. Okay, so if we do delete an object. So my plan is to update each frame all the object data, and so that will be, so all this will be in some sort of CPU side buffer, right? So if I delete one out of it, that should be fine because then all the indices will update, right? Because I build the command buffer based on the number of entities. So if I then also loop through those entities and build the object data list, then they'll all be in sync. I guess the alternative way is that rather than updating all the data every frame, each entity CPU side understands where in a corresponding buffer its object data is and updates it when you just update that one. But that sounds like a lot more bookkeeping than I need right now. But let's see how we get on. Let's see how we get on. So objects, and then map for, no, sorry, this is going to be object data objects. And I think that's all I want. And then we should be able to do map for get object int index and return, I guess, object. I suppose there's literally no point doing that because I don't have to do any transformation. Ignore that. Okay, so then model becomes objects GL draw ID dot model. Right. Thank you. I will try and drink water. In fact, completely, mate. Okay, so this should be fine. So we get we get basically an object data per render command effectively, and then we can index into that. So now we need to start building what that data is going to look like. So renderer, for a start, we're going to need a what's that going to look like? We're going to need a source graphics object data.h. Probably wants name space oops hash include maths matrix 4. Oh, get rid of that. Matrix 4, and then something like struct object data. And this will have a, so this is the CPU equivalent, side equivalent of the GPU buffer that we just declared in the shader. Matrix 4 model. Okay, and then if we go to renderer, here we're going to want I probably want a multi-buffer persistent because we're going to be updating this every frame. Again, I'm not saying there's not a better way of doing this, but this is sort of my initial first thought. Object data buffer. Okay. Renderer. Let's bring in include core graphics. Object data again. Does object data go in graphics or does it go in core? Yeah, I think due to the kind of iterative nature of this, I will just sort of spring up new buffers as we need them, and then there might be a chance to simplify that code later. So this will now need to be object data buffer. I guess the initial size will be just the size of object data. And this will be the object data buffer. That is interesting. Yes, I see. So the question is basically, the point being made is that this assumes that every per object data I want to track CPU side, the GPU cares about. I think we'll leave this in graphics for now. This may eventually become something like GPU object data, but for now, like both sides of the equation, both sides of the coin care about the same thing. So let's keep it simple and stick it all in one struct. We might have to refactor this later. That's a good point. Okay, I'm going to try and remember how this works now. So we build the command buffer, and then basically I need to do something like, Well, actually, I guess for a start, entity will need a... Okay, fine. Let's bring from our previous project something in. Let's bring in the transform object, source maths. So the transform is just a high-level thing that we use before to encapsulate the position, the scale, and the orientation of an object. Oh, I need to bring in quaternion. That's exciting. And then this just gives you an access to the matrix. This kind of handles all this governs for you. So the entity itself will have a transform, and then from that we can calculate the matrix. Whether we should be doing this as we go along or just when we need it, I don't really know. It kind of worked right last time. So let's copy game source maths quaternion into source maths G quaternion S UFPS. Sorry, search for game, replace it with UFPS G, I think, something like that. My quaternion is pretty shite. We did not need to do any quaternion maths last time. I think the only quaternion maths we needed to do was in the matrix class, which I think I deleted, so we need to bring that back. Thinking about it, what did that look like? VS game source maths matrix 4 quaternion. So I can construct it from a quaternion, so from a translation, from a scale, from that. I'm pretty sure that maths works. That's the only one I need. Okay, that's nice and easy. Okay, so we got that, and then we go back to the transform. That should now work. What is it not like? I don't know what point const expra constructors were introduced, but they have been a thing for quite a while. What do you not like about this? I guess the compiler will tell me. Okay, so if we go to entity, then we can do --include maths transform. Give that a super sweet, obvious name. Okay, so now that we can give the entity some sort of concept of its place in the world, back to the renderer. Then we need to convert each of these transforms into the buffer. So multi-buffer. So I think we just write it in, and then persistent buffer, when you write it, that doesn't do the resize. So where do we handle that resizing gubbins that we had to do last time? Yes, I'm trying to do the graphics, and I think bangret might help you here. Because I can't just write into it because it won't resize it. Where does all the resizing, the buffer resizing come into it? I thought we did that in persistent. We wrote, there's a whole load of like doubling logic. Where was all that? I thought it was in multi-buffer. Oh, it sits above that in the mesh manager. Okay, fine. What am I gonna do? That's such a pain. And I guess as well, it's in the command buffer as well. I'm gonna need another class, aren't I, to abstract this? The mesh manager, yeah, because it's when you load a new mesh, it has to know. I guess the question is, should this be pushed down into the individual buffers themselves, and they dynamically resize themselves? At the moment, once you allocate a buffer, that's kind of the size you get. So if you need to resize it. So we already effectively have a resize function. Like this just needs to be pulled out into a util function, okay? And this will resize a GPU buffer based on a CPU buffer and a GPU buffer. This logic just probably needs to be pulled out into a free function, and then we can kind of call that wherever we want. I think that might be the simplest thing. Vanberg, hello. Okay, let's create what is almost certainly going to be the first of many util functions. So source graphics utils.h. In fact, actually, this will help out a little bit, because then we can just stick that in there. Get rid of this. And then bring that, that's going to need to be in here. And then what else are we going to need? Hash include vector, hash include string view, hash include, give me, hash include utils. Nope. Sorry, my brain is not quite with it today. Buffer, okay. That actually might need to be templated on a buffer type, because we might want to do the same for multi-draw for persistent buffers. Codingram, hello. Okay, so now we should be able to hash include util, graphics utils. We already have a utils directory, so I don't know if there should be a utils/graphics.h or a graphics/utils.h. So let's template. I kind of think utils is top level for everything, but then each module, I guess, might have its own specific utils that are only expected to be used within that. I guess you're namespacing this within the graphics. But I think I'm going to leave it here for now, because my view is that you've got the top level utils, and then you've got, so top level utils are like the primitives like auto release and the logging stuff, whereas this is very specific to graphics, so I think it should live here. I guess we just make that, and then don't include that. But I will need to include graphics OpenGL, which gives us access to GL finish for the barrier, and then this just becomes a new buffer type like that, because all the buffers have the same interface. I guess we could technically do template. Do we want to restrict that on I already have. Interesting. Okay, fine. So this here needs to move up into the utils as well, right? Hash include utils data buffer. And size t is in c_def. Alright. Yeah, well, I already had the concept written, so let's bring that out here. Then we do hash include. What's that source? Util graphics utils. Okay. Concept is just a way of effectively restricting template instantiation. It's a more modern spinne, if you're familiar with that. It basically means that I now do is buffer here, and it will only let me instantiate this template with something that matches this concept. This concept being it has to have an object with a write function, and that write function has to take these two arguments, i.e. all my buffer primitives you'll be able to write to. So it basically restricts it to that. And you get basically slightly nicer errors. You could not do this, and then you would just get a miserable instant template. And you could not do this, and then you could just pass in anything, and then when the template becomes instantiated, then you'll get a miserable error. But this should make the error slightly cleaner. That sounds like a short. They'll sneak up on you like that. Okay, fine. So now we can resize the GPU buffer based on our sort of doubling exponential strategy. We're restricted to something that is buffer-like. I think that's okay. So now I will integrate that into the command buffer later. I don't want to change too much stuff as part of this. So if we go to back to the renderer, we should be able to graphics utils, bring that in. Is that because you've eaten too many pie rings though? Okay, so after we bound the command, so that's kind of like those things there. So before we do the draw, we need to resize GPU buffer based on the. So hang on. Where's all this gonna? Where's my CPU side buffer for all this? Am I going to build it each time? That seems wasteful. Because we could do const auto. So the way I've done it in the moment is we do have a scene object, right? And the scene, I need to move this into core, by the way. I will move this. The scene has a bunch of entities, and the entities themselves contain the transform. So I guess the easiest way would be to do object data equals scene.entities stood ranges transform const auto e return object data dot model equals e dot transform dot transform. I think the implicit cast should work there. Stood ranges to stood vector, right? Oh, hang on, it's not ranges, it's views, sorry. And that is a lambda. Yeah. Yeah, sorry, get there in the end. So it just means per frame we're doing a big allocation because each frame we're having to build it up. I guess the renderer could own that and then just run through and update it each frame. There's going to have to be copying somewhere anyway, right? I think for now that's probably okay. It's not ideal, but it does kind of get to where we want to go to because now I can resize the GPU. Yeah, that's the other thing is we could just let me just get this working first, and then we'll refactor it later, because I feel like otherwise I'm making lots and lots of changes and not getting anywhere. Yeah, I think there's a variety of ways that we can do this. Let's take the path of least resistance and get something working first, because we're kind of need 45 minutes into the stream, and I really want to get this rendering, and then we can kind of tweak it later. So resize GPU buffer, object data buffer. No, hang on, it's going to be object data buffer, and then the name of it is object data. So that will resize it if it needs to, but I think it always copies the data over. No, that just does the allocation. Okay, fine. So then, what are you not liking about? Does my okay, fine. Multi buffer doesn't expose a size. Oh, what is the size in this case? Because it's triple buffered, it'll have to be. This needs to change to just be size, right? Original size. Is the requested size? Yeah. Okay. Fine. Size becomes size. I think that's right. It's going to break something else, but that's fine. We'll fix that in a minute. Okay, fine. So that now works. So we can resize that. We then need to do object data buffer dot write stood. Isn't it? I think I missed this last time. Isn't it stood as bytes? In span, yeah. So as bytes. I'm going to write the object data in with an offset of 0 u. Ranges and hash include span. Oh, does that not work on a vector? I thought that automatically does take a span. I guess it won't implicitly cast that. Object data size. Span. Okay. Not sure if that's better or worse, but okay. I'm trying to write a renderer. That's what I'm trying to do. Okay, so that will take the object-specific data, squirt that into the GPU, and then all that's left to do is then bind this to 2. Oh, that's typo. Okay. I think that's right. Take all the object data from the scene, we linearize it into one big array of all the bits we need. We then check to see if that means we're now rendering more than we were before, and we'll resize it. We will then take all that data and write it straight in, and then we will do that. And then at the end of this, we'll need to advance the internal bookkeeping for that multi-draw buffer. Or have I bound? Have I copy and paste? Have I got copy and paste there? Ah, well done. Well done. Okay, fine. And that will become object dot native handle. Okay. Outstanding. Okay. I'm trying to make a first-person shooter, but we'll see how far we get. Okay, so that will actually probably not work because by default the entity will have a default constructed transform, which gives it a 0 scale. So let's try this. So let's do dot. No. Nope. Let's try dot transform equals let's stick it away from us. So let's do 0.0f 0.0f minus 10.0f, so some way in front of us, and then give it a scale of 10, and then let's do 5, and then a default rotation. Why is it not liking that? What do you mean expected? Like that? Okay. Yeah, that's easier to read. Should the type of what be different? Let's see if that. Let's see what that does. I suspect it won't run. Bleh. Oh, I did change something else, didn't I? So there's going to be other errors somewhere. Bind as a shader type. Okay, fine. Let me fix that first. No, it's an SSBO, so I think that's right. No VBOs here. Only the finest vertex pulling. What have I missed? I think that's right. Matthias, resubbed. Thank you very much. I advanced the command buffer. I advanced the camera buffer. I advanced the object data buffer. I bind the SSBO. I think that's right. Let's look at these miserable errors. What's it complaining about? That's. Ooh. There's an error. This is very much indicative of an error in a header file somewhere that is included in multiple places across multiple translation units. I can see it's all this format stuff. What is it not like? It doesn't like this, right? Why does it not like this? It's very much. One of these it can't print, and I'm going to assume it's the rotation because it's the newest one I've added. So let's quat. That has a two-string method. Oh, have I got to include the formatter? Yeah, thank you. That's the one annoying thing. I really wish I didn't have to do that, but hey ho. If it was a perfect language, we'd have nothing to complain about. Okay, this is fine because I know I changed this. So this is the command buffer 96. This just becomes size. I suspect maybe some tests are now broken. Quaternion, a way of representing a rotation in 3D space. I don't know. What's life without whimsy? Let's choose to mispronounce it. Multi-buffer, command buffer, 71. Okay, fine. So an S original size becomes size. Where else have I used that? Original size in the tests. QB, go up through those, rerun that command, bish bash bosh. Boo. Okay. I have a syntax error in the shader. Okay, that's fine. In the sample vertex shader, failed to about that. Nice that we got the names coming through now. Line 26. The annoying thing is I don't actually like line 26 from here, I guess. So let's see if I can see. I don't really. So I suppose I could probably actually do 26J, and that will take me down. Yeah. Okay. So there you go. Undefined objects. I thought this just doesn't this just vomit this into the. Is it because I've called this twice? But I thought this just vomited this into the global namespace. Oh, did it say already defined? Object data, fine. I don't like it, but I run Windows 11, but this is WSL. Bobo, thank you very much, much appreciated. Am I? I think we need to shift this to the right. Let's shunt it along the x-axis and see if that makes a difference. I just want to kind of convince myself this is working. Okay, fine. That's nice. Easy. Nailed it. Bish bash bosh. Done. The actual... Didn't I need to change something in command buffer? I need to get rid of this, right? Because I can replace this with... Oh, that's a range. Include graphics, utils. So all this goes away because doesn't this just become resize GPU buffer? Command buffer. Command. That's a typo there. That shouldn't be mesh data. That should definitely be command buffer. Maybe it might be easier if the GPU buffers store their own name and then we could pull it back out, because having to do this every time is a bit of a pain and it leads to copy and paste errors. I think that I might just put that on the to-do list actually. Let me just capture that whilst I remember. Add item to tech debt. I want to have GPU buffer store name. Create. And then I want to, what was the other thing I want to do? I want to because I'm not sure if I'm going to do it this stream, refactor object data CPU buffer. I'm sure I remember what that means. Hello. Okay, fine. And then I just write it like this. Right, I think that's what I want. CPU buffer into scene object. Thank you. Yes. Or I'm not sure if it's going to go into the scene object. It might go into the renderer, but it needs to go somewhere. Okay, fine. That works fine. Tests. Don't break anything there. Cool. Okay, let's just quickly stick this in the Git hole. Add object data struct. Didn't I add something new? Transquaternion. So I got tests for that. Game tests. I suppose there's nothing to test, is there? Because it doesn't do anything. Right, add quaternion class. Correct. Add transform class. Correct. Construct matrix 4 from quaternion. I know, I made a mistake. Okay, I'll go to double check in a second. Construct. Oh man, it's all going wrong today. Reword. Construct matrix 4. You're right. I should. Oh my goodness. Matrix 4 tests vs slash source. Sorry, game tests matrix 4 tests, and then there's a quaternion one in here somewhere, isn't there? Oh no! Apparently, I never tested that. Good. I know. I'll add that later. That's one of those things I'm kind of happy to do off stream, is just to update the tests. Okay, fine. So okay, add resize GPU buffer util function, and then this gets integrated into multi-buffer mesh manager and command buffer. So integrate resize util entity stores transform. That missed that. Where is that? That would be part of this. So append that. Commit. So the render will now be. So the render will now store object data in GPU buffer, and then integrate object data into main. Okay, cool. Nailed it. Yeah, it is lazy git. Okay, so that's nice. What's the next thing I want to do? I think now I want to have material data, which will be a separate buffer again, and then we'll just track an index into that. Let's do that. So let's supply the. So let's remove that from the vertex data. Vertex data. Hear that. Good spot. Cool. So I want to bring in the material information. So I'm probably going to need a material manager for this, because you will need to be able to construct materials. And I think this might be the first case where we want to be able to remove stuff from the manager. So mesh manager just assumes you create everything at the beginning, and you know those just always there loaded for the level. But materials, especially if we have like an editor, we'll be wanting to maybe change those as we go along. So what does our mesh manager look like? I think it's pretty simple, right? So this maintains a buffer of. It's going to look very similar to this. I'm not going to, but I almost feel like there should be a templated manager class. I'm going to probably use Jolt. So let's do e source graphics material manager.h and basically sketch out what I want. So this is going to look probably slightly different to the other one because we're going to need UV support come later. If we can get all this done now, then I suspect textures will be the next stream. I think we're going to want some sort of handle back to this, and that handle will be an index. So let's go back to the renderer and sketch out what this is actually going to look like functionally. So we're going to have another struct, right? Okay. So the moment this will have float color, what it'll eventually have is something like the handle to the albedo texture, the handle to the normal map, a handle to the specular map, a handle to the whatever emissive map. So all that, and then multiple objects can then be rendered with the same material. The specular amount, all that kind of gubbins, is going to go in here. Yes, it's British spelling, I'm afraid. And again, this is not necessarily... The reason I'm extracting this out is because there's not a one-to-one mapping of materials to objects. So for everything we want to render, it has to, pretty much by definition, have its own unique object data. However, multiple things might share different materials. So that's kind of where I'm going with that. So again, we're going to have... materials, and then this will be material data, something like that. Okay. And then this object data will now have a uint index, right? So each object data will be like, okay, you were going to render this object at this position with this material. But that needs to probably go across to the fragment shader, because out color now goes away. So it gets rid of that, get rid of that. But what we will have actually is out uint material ID. Now, correct me if I'm wrong. I think I want, is it fixed? I don't want it to interpolate across vectors, across vertices, right? So in, sorry, that's still 0. Uint, is it uint? Is it uint in GLSL? We've got int. Is it just int? Is there no uint? Material ID. Okay, fine. Harand, do I want fixed here? Is that what I want? Does that stop it interpolating it? Or, varying it? So I get the int. Material ID. This actually then needs to come out here. So let's do... I don't need, at the moment, I suppose I better just have it in here just for sanity. Let's bring this down. Stick this here. It's going to need the same layout number, even though there's nothing else in there. So that'll give the material data, and then out color will be vec4 of material. Hang on. Get color material data. So this will become get color of material ID. No, I don't think you get GL draw ID in the fragment shader. I think you have to pass that over. Also, I don't want the draw ID. I want the material ID, which comes in the object data. I guess you could use the draw ID to pull that out, but I don't think you get it flat. Thank you. Okay. Again, a little bit of abstraction there, but the idea is that we kind of start putting all the data we need in different places, and then it's kind of easy for us just to update those where we need them. It should all coalesce in some beautiful harmony of graphics. So that's the GPU side done. I say done, it won't work, but at least it gets us somewhere. So then the material manager, we need access to that ID. So I think basically the issue is if you remove something from the material manager, it will invalidate all the indices. So say we had something like auto add the unit 32T. I don't know what that's going to take, right? So I'm gonna talk for a bit. I don't think so. There's a couple of questions here. One is updating the material going to be a frequent operation? Do we want to multi-draw it? It's more of an implementation detail. I think yes, because if I wanted to have something flashing emissive, I might need to update some material data on it per frame. So I think we should assume that's going to happen. But say you had then auto remove. Right. So whatever this means, I call it and I add it and I get back an integer, right? So object data then has that includes c std int ID. Okay, fine. So this now matches the renderer. Okay. Object data has an index. Okay. I think 430 will pack that correctly. But what happens if I need like the object wants to? I get what you mean. I guess that's part of my question. Is it weird to have that? Like if I wanted to change a texture map, like a texture ID on something, but the main thing I think is like I kind of want to have some sort of concept of emissive material, and I would like that to maybe change over time. You know, to have things glow. When we do bloom, you can see it kind of glowing and changing color and stuff like that. So I think I'm going to go down that route. To be honest, it doesn't really, at this point, it doesn't really matter. That's more of the underlying buffer information. But if you wanted it to flash, so what I'm thinking of is like, say you want something to glow, like pulse, you would maybe want it to cycle through 60 different values, one a frame, you know, and then back again. I'm not going to add 60 materials, one for each different with an emissive factor. So yeah, I haven't really thought about entity/instance data. That I guess that's kind of the question, right? Or do you then just shove that in like entity and then have that pushed up there? Okay, let's not worry about it now because it doesn't matter. It doesn't matter because it's just basically that question there. The only material difference it has is what buffer type do I use? Do I use a persistent buffer or a non-persistent buffer? At this point, it doesn't really matter. My bigger question now is like, how do we wire this up when we might have, especially if we've got like a little level editor, we might be creating lots of materials on the fly. How do we handle it such that the indices might change? I do have. So my thought is like the way I solve most problems is with like another layer of indirection. So we could return some handle here, right? And then at the render time, right? When we build up this, we use that handle to resolve the index as it is at that point in time, and then submit that. I think that's right, because then if we do multi-draw data like multi-frame, then it doesn't matter if that's changed in the next frame because those indices are still valid for the previous frame. So I had a thought about this, and basically I'm going to implement it a specific way because it's a new C++ feature I want to play around with. I don't know if it's the correct answer or the most performant answer, but I kind of want to play around with it. So what I was thinking of is all right. Key third EN 32T key key like that. Probably no reason why that can't const explorer. And then const explorer auto con explorer auto key const the unit 32T. Gonna have key.key at some point, but that's fine. Okay, something like that. Okay, and then const explorer auto operator spaceship const equals default. I think, can you? Oh, it's whatever that extra I can't remember what it is. Yeah. Oh, can you not default the? I thought you could default the spaceship operator. Yeah, get might be better actually. To be fair, we could also just overload it on there. We could do const explorer auto operator star const the uint32t return key return get. I'm shocked. I thought you could auto overload that. That's a massive pain because I'm gonna have to do it the hard way. C++ default spaceship operator. What I want is this to be the default comparable as if it were an int, right? Because of the data structure I want to use. I thought it would synthesize this for you. Oh, do I need to take const key other? Like, I don't know, like, what am I doing wrong? Auto operator const equals default, where it takes the other type. Oh, interesting. Do I need some magic? Ah, good spot. Well done. I bet I can make that const explorer now. Okay, so what I need is to return some sort of handle, i.e. this key, that, again, doesn't matter where the stuff moves around in the underlying data, I can retrieve the index for it. But I want everything still to be contiguous in memory, because what I want to be able to do is I want to be able to upload all the materials, buffer all the materials in one go over to the GPU, right? So it's still, so the requirements is basically I want all the data to be held contiguously. I need to be able to get the index of that and return some sort of key. What I'm thinking, right, and I don't know if this is the right answer or not, is a flat map. Only because I really want to use a flat map. Stood flat map key, and then well, I don't even actually have the material. Do I have material data yet? Struct material data. Hash include maths, graphics, color. All right, and then material data. I don't know. Cherner's pretty busy at the moment because he's just started like a new role. So I've chatted with him a little bit since that. I think we're still both keen to do it. It's just finding the time. So what a flat map does is it basically maintains two vectors of data. Flat map. It's a container adapter. Okay, so it has to take, the key has to be less comparable with the less than operator, which is why I wanted the spaceship operator defaulted to that, because that kind of gives me the ordering. And then it basically, when you insert something, it inserts it with the key, and then it makes sure that whatever the index the key is at is the index it is into the underlying data. So the idea being is, hey, what's the index of this handle? Then I know that the data is at that corresponding index. But also, I should be able to get access to the underlying data values, right? So this will give me access to the underlying vector. So it means I can still squirt this vector straight into the GPU. That's the plan. This feels like an interesting use case for it, and I've not had a chance to really play with FlatMap yet, and GCC supports it, so I think we'll kind of give it a go. So we're going to add. So it will be whatever the operator complexity will be the same as the underlying container that it's adapting. So it'll be the vector. So it will be n in the worst case and log n lookup. So again, I guess the question is the bottleneck, where would the bottleneck be? I think having the access to the contiguous data and the fact that we can kind of iterate through the keys and get the indices out, I think might be okay. Otherwise, we'll just use an unordered map and we'll just hash the key to the index. But the idea being here that, say I get back some key, and from the point that I've inserted it to the point where I need to use it, other stuff's been added and removed and it's all moved around. I can always resolve the index of that key at that exact point in time that I need it, and then again take the underlying vector data and over to the GPU. So I think that's fine. Indeed, Cat was scratching at the door and then realised if I open the door, that is what's waiting on the other side. Cat has now gone. Okay. Let's just give this a go, right? It could be a total disaster, but I really think it's worth giving it a go. So we're going to add. We could actually do something like this, right? hang on. I always get this wrong. Args. And then we could do, so let's do static auto key num equals 0. Material data dot in place, I guess. In place key num plus plus stood forward args dot. Alright, and then actually I should be able to just return that. I think that's right. I thought just in place would give you the key back. To be honest, like this is a new world for me because I've not actually used flat map yet, so I'm kind of interested to have a go around with it. Construct an element in place. So you can in place with the key and then the arguments, and then the return type is an iterator. Inserts new element into the container constructed in place with the given args. If there's no element, then the key is the container. When the key is in the container. So the return is a pair consistent iterator to the. I don't want. Yeah, I want to get back the key. Yeah. I guess it doesn't actually matter because what we're going to do auto key num plus plus, right? And then we are going to key auto key equals that. Const auto key equals that, and then return key. That'll actually work, I think. Well, I think it returns an iterator to the inserted element, not to the key. I think that's the issue, right? That's what you get back. Is pair consistent iterator to the inserted element. Yeah, unless the iterator itself contains both. Implementation time, random access iterator. Yeah, I don't think so. Hello. I think that's fine, right? Because these are. I think this is fine, right? Because this is the kind of important bit. This is the bit that is associated with the data that you're pushing in. And then the index is somewhat irrelevant because then we can just look it up by this. I do think this might just end up being a header-only class. Yes, but the key difference is that with map, it's all heap allocated with nodes. It's a red black tree, whereas this maintains contiguous data. So I should be able to then I should be able to return that data, right? So let's do auto remove to be honest, actually, just a tiny object, isn't it? Just take the key by that. Nope. So I need. Does it have? I bet there's no erase at override for this. Oh, it does have erase if. Or do I just? I'm wondering if the easiest thing to do is just copy erase, or can I just do std erase material data key dot key. don't know. So interesting. So I think it might actually be easier just to do erases all elements specifying specific criteria. That will iterate through all of them, checking for all of the keys. Well, I know there's only going to be one, so I think actually it might be easier to do remove arrays, because you. Oh, okay. No, you can just erase by key. That's super easy. Oh man, that's super easy. So I should be able to do material data dot erase key. Nice. Well, again, like I want the data to be contiguous, right? So I want to be able to do auto material data. It was actually, I guess, just data const return material data dot values. So that should return a stud vector of material data. I think it's const ref. Because I need to also back this with GPU memory as well, so that's going to come in a bit. In fact, probably now. So then we're going to need a include graphics persistent buffer. Again, I'm kind of figuring this out as I go along. I don't really have much of a plan for this. I just wanted to kind of give this a go. Multi buffer, okay, and then so that's multi-draw, multi-buffer, persistent buffer, material data GPU, and that would be to erase a CPU. Okay. Something like that. And then we're going to need a auto native handle const return material data GPU dot native handle I don't really like get in getters personally, because I think it's normally obvious that they're getting. So it could be raw. It could be, to be honest, it probably actually should be values. Although then that kind of leaks implementation details. I'm going to go with data for now, and I reserve the right to change my mind later. Okay, so now that we can do this, when we add something, we'll need to potentially resize that as well. So let's do graphics. Well, I've stopped utils. Thank you. We might not even need this, to be honest. Apologies if there's background noise and stuff, but I'm not an audio engineer. I do the best I can to kind of create a setup that works. It doesn't work for everyone. I mean, I can look into it. I could probably change maybe the filtering on the background noise. It's a small room that's quite echoey, so I have to have quite a lot of filtering anyway. No, I want to deduce the return type here because I don't know what the underlying, if this changes. I mean, it's always going to be a GLUint, but for the sake of arguments, we should deduce it to be whatever the return type is of the actual native handle. So I'm going to leave that. I have chosen to deliberately omit it. Okay, so when we add something, we will also need to, before we do that, resize GPU buffer. So the CPU buffer now is, I guess it's probably called data, and then material GPU data, and then this is going to be material manager buffer. Yep, I know, I've seen it. Shouldn't need it because I think that's already that already happens for us in this call here. Okay, so then all we have to do now is construct this material manager. Material manager CPU. Whoa. Material. Material. Oh Jesus. Material GPU, and then this will be a size of material data, and then material manager buffer. Yes, good spot. Good spot. Because it might have grown. So basically, we can add something in. If it causes the thing to regrow, we'll also resize the GPU buffer. This will also need a auto. It's going to kind of leak data there a little bit, which is annoying because we'll have to advance. Because we'll need an advanced function, which is a little bit annoying to have to leak that implementation detail. Rather, the call will be agnostic to the fact that it's a multi-buffer, but it's not really a lot I can do about that. And that will be a void before someone shouts at me. Okay. Yeah, I think there's probably some more abstraction to do, but let's kind of get something going first. Okay, so the only thing missing now is we need to be able to resolve the index. So I guess it's really what we want now is auto index for a given key. Understood. We'll have to downcast that, but that's fine. Const. Hang on. Utils error. Const auto. I want to call it index again, but I don't think that's going to really help. Element equals stood. Stood ranges find material dot keys key, and then we're going to expect, not ensure, because we don't want to widen the contract. Like, you should only be calling this with a valid key, but we'll check for you in debug. So elements does not equal stood ranges the end to data const auto keys equals keys could not find key key. I suppose I should probably have a formatter for that, but one thing at a time. And then we want to return stood ranges distance of stood ranges the begin keys elements. We might need to static cast that, but down, but I think that's fine. What does it? Oh, does it have find? Oh, whatever. I've done the. Oh, actually, probably do want its internal find, because I wonder if it will do a binary search internally because it knows they're ordered. Because and you do get an iterator back. Okay, fine. So let's do expect. This might actually be slightly easier then. Expect material CPU dot contains key could not find key. I'm gonna put key there because I will have to. I'll add a formatter in a second. Fuck it, just do it now. Hash include string. Hash include utils formatter. Okay, so then we should be able to just do context. Oh, I don't know if that's auto to string const stood string return stood to string key. That should work. Okay, fine. So we'll expect that. Then we'll do const auto element equals material CPU dot find key, and then we will return stood ranges I think that'll work. Okay. So now we have we store all the material data in a contiguous buffer. We have an abstraction which allows us to give basically a persistent handle to any of those elements, regardless of whether they move around within that persistent buffer. We can resolve that back to an index, and then that means we can push that up to the GPU. I think that's largely what we want. So Seam will have to sort of bring this along with it. So let's wire this up into main. Hash include graphics to manager. So we're going to construct one of these where we create all the other gubbins. auto material manager equals UFPS material manager. Excuse me. So dot material manager equals material manager. That is true. Good point. It doesn't actually matter because it would be stripped out and debugged, but we might as well adhere to it. Expect element does not equal stood ranges to the end material data CPU. Okay, right, good spot. Okay, so we've got that in there. We now need to probably create a material. Let's change the color, I guess, a bit so we can kind of prove to ourselves that this works. So create the scene, create that, and then we'll do scene.materialManager.add, and then this will be a UFPS color 1.0 F 0.0 F 0.0 F. Well, actually, we need to probably do this earlier, don't we? So this will be const auto material key, and then when we create the entity, we can do dot. Yeah, we'll try and do two cubes of different colors. Let's just try and get one in there first. Where's that going to go? I know that narrowing issue. I can fix that in a minute. I'm just trying to think where the ID is going to go after that. Do we say it's going to go in the? It's going to go in the entity, right? Or does it go in the object? It goes in the object data. Okay, fine. No, you. Okay, fine. That's different. That's material ID index. Okay, and then the entity has. Ugh, I don't like the fact that I have to bring this whole thing in, but it's fine. Graphics, material manager. This will have a material manager. Sorry, a key. I hate that. Material key. Material manager. Change that in a bit. Key is a little bit too ambiguous for my liking. Dot material key equals material key. So now I just have to resolve those in the renderer. Okay, that's fine. So each entity now has a view over the mesh data that it needs, the transformation that it applies to, and then some sort of handle to a material. Yeah, I'll probably put it out into a separate head file. Let's just see if we can get it working first. So the renderer now, this has got to, Christ, what's this got to do? So this here needs access to the scene, because what it's going to do is it's going to do const auto index equals scene dot material manager dot index of the e dot material key, and this becomes dot material ID index equals index. Okay, that's goes in there nicely. We stick that into there, and then the final thing is to do scene dot material manager dot I combined it, but now I have to also write it. Oh, I think I know what I need to do. I think this changes slightly. That's fine. Rather than having native handle here, we can just do auto buffer and then return material data GPU com. How do I do? How do I do with the command buffer? Oh, does the command buffer have has a build, doesn't it? I wonder if I should have something similar. Let's do keep that and then do actually no, let's keep it const multi buffer persistent buffer that, and then we can just do return material data GPU. Okay, it's fine. So now we can do. I don't like the fact that all these different abstractions are kind of leaking their internals in slightly different ways. Like, you know, the renderer has to resize the object data GPU buffer, but the command buffer resizes itself. I think there might be a chance of reflection at some point where we kind of unify these a little better. But for now, like, because we're building this iteratively, I think it's okay. So let's do scene dot material manager dot buffer, right? Dot material manager. Steady. Dot right. I do feel like this maybe should just be part of the class itself. We should be like update it and then it automatically copies the data over rather than you grabbing the internal buffer out. And then you can just get the native handle out to bind it. I guess that's sync. So this will do material data GPU dot write const auto values equals material data CPU dot values. Get a reference to that. What have I done? Why is all this code suddenly exploded? Oh, is it just because I've not finished this? Okay, fine. And then we're going to write there std span of values dot data values dot size times size of no, wait a minute, sorry, values dot size stood as bytes 0 to u. I think that's right. So we're going to take all the underlying data, and this is the advantage of using flatmap, is we know it's all contiguous. We know that all the indices have all been resolved based on the keys, and square it into the GPU. That's right. And then, because then all we have to do in renderer is just do scene dot material manager dot sync. And then unfortunately we still have to do this. I'm tempted to push all the binding off into the individual like owner classes, but for now I think that's what we want. Great. See what happens. That's tests. Hopefully those still pass. I do have errors though. Right. Okay. Fine. Oh, I've got right. I do need to change this from key because I already have the UFPS key, don't I? Yeah, and this also is the key press. So let's do %s key with material key. That's a little bit better. Material key, material data. I think that sounds a little bit better. Yeah, there's a bunch of narrowing here. Wherever it will be here, I imagine. Because distance will return a size t, but I only care about uint those two t's. See what happens now. There's now more errors despite having fixed those. Right, what is all this? Entity has no name material key. I think it. Oh, of course. Now it's material key. Okay, it's getting shorter. Don't care. Vertex data is non-static. Yes, you are correct. Because that is now gone. So that should just be that there. Indeed. Not unexpected. 50 in the shaders. Render. Have I just not updated all my variables? Out color. I don't need that anymore. That's fine. I was just missing that. Because I just want to pass over the vertex information. Implicit cast from uint to int. I suspect that is here, and I suspect I actually do want that to be uint, because why would I ever have a negative index into that? So I think that's supposed to be there, and that should be there. I don't set the material ID. I think I set it here. I set the key there, and then in the renderer, when I build up all the object data, I set it here. So I'm pretty sure it is there. Oh, in the shader. Okay, fine. Well, you send across the... Oh, you're right. You're so right. Equals object data GL draw ID material ID. I've already got a mismatch of names now. I've already okay, fine. Apparently it's just I can't just be calling that index. Let's try and keep this a little bit sane. Like, it's already quite complex. Right, okay. Why have I still used material ID? Oh, there. This will work. There's no reason for this to not work. I'm trying to render a cube. Oof, oof. Cool. It cannot link my program. Does it have to? Okay, fine, that makes sense. Also, where does it go? I assume it is after the in. Got to flatten out that integer. I feel like it's should be giving me. It just failed to link. I feel like I should have more information than that. Why is the log empty? Like it's. It just means it does. So normally you OpenGL will automatically interpolate values between the vertices. So that's why when you draw like hello triangle and you set a color at each vertex, you get that blending of colors between all of them because it's interpolating them. But because I'm passing in an index, like it has to be the same across all vertices. So I don't want it to interpolate it. Yeah, it's not got around to doing the file IO yet. It's just not on my it's way further down the to-do list. I want to just build out the rendering tech with some simple shaders first. Why is this not working? I feel like this should be giving me more information. I don't know, because I think it's fun to do stuff in OpenGL. Like, I think it's well, it's not fun at the moment, but when it works, it's fun. Why would it fail to link and not tell me why? I guess one is this invocation correct here for getting the error out? Is it? Do I want GL get program info log? I guess. Where do I call check state? Which one of these is it? 47. So it's the first one. It won't link it. So it does suggest that it doesn't like something to do with the variables in between the two of them. I don't know what the debugger is going to do because it's not. It's like it's running. It's just open. The OpenGL driver is saying no. I have no idea how to debug that. Yeah, I mean, if you want to keep up with modern C++ stuff, like the easiest way is probably to go to if you go to the C++ compiler support page. This will tell you which compilers have implemented which versions in terms of like the language and the library. And you just sort of scroll down, and this is basically your checklist of things that are coming in each version. Just pick the ones that you find interesting and have a play around with it. Like I knew flatmap came in 23, and I wanted to have a play around with it, so I'm using it today. That's largely, I guess, my advice. This was working fine before I introduced the flat. Does flat even make sense for you, Ints? Would it interpolate those anyway? Like if I just, it might cause my GPU to crash. But if I just remove that, ooh, it does not like that. Won't link that. Why would it not link that? Is it to do with? Can I just bind straight to 2 here without having the previous ones? Because it's not a syntax error. Yeah, but I can't even get the shader to run. That's the problem. Like it's not even like it won't link it. And I don't get why the log is empty. Like, turns information on for the specified program. I mean, it was running earlier. Maybe, yeah, I guess we could try adding the other bindings in. It's a little bit annoying. So where do we want to go down to? 56. I guess something like that. We'll have all of them. Yeah, because one's an input. There you go. It was just missing that. That's fine. The question was, what is having 2 layouts fine? Because this is the layout for the ins and this is the layout for the outs. So then they both start at 0. So that's why that's kind of okay. Okay, that's fine. Okay, let's go to main, and then let's see if we can just push in something else. So let's create a material key red. Let's create a blue, and let's create a green. So RGB, and then RG. What I want to do now is I want to do material manager dot remove material key blue. I want to just kind of check that that works, right? The idea being that this will force the indices to change, but hopefully the keys are still the kind of the anchor to that. Okay, so this will be, so we're going to do red, and then push another one back. We're going to stick this at the positive side and make this one, what did I remove? Blue. So I want it to be green. Okay, fine. No, I removed blue. Okay, fine. So this should give us 2 cubes. I feel like I now just have one. Whoa, something's really wrong here. This is massive. What is this? It is indeed. Okay, fine. Let's not remove this. Let's just see if that's the issue. Yeah, that is massive. No, because it's something to do with adding this second entity, right? Because if I remove this, what am I checking the alignment for? But okay, sure. Let's fire up. Let's fire up the dock. Rebuild. Give me a second while I just fire this up. Home, me, projects, UFPS, build, source, debug, UFPS, right, launch. Okay, what am I looking at? What am I checking? I guess mesh, pipeline state, vertex shader. So it might. Yeah, is that being padded? Yes, here. This is it, isn't it? Press the green arrow. This green arrow? Oh, this green arrow. Yeah, fine. Okay, so I think you might be right. I think what's the... Will that be padded to 4 bytes? Oh, to 8 bytes? So do I need to put some padding at the end of this? Okay, fine. That's fine. So it's renderer. So like that. If you find an easy one, let me know. Okay, fine. So, on the CPU side. Okay, fine. Of course, because it's already padded. Yes. Okay, fine. So object data. Third. Okay, I could just do that, right? That. Fuck's sake. Boom. What? Is it? Okay, well, it's now the right... Oh, there it is. Is my camera facing the wrong way? feel like it's not like what I wanted in terms of my expectation of where the camera is. So oh no, it is right. I'm just an idiot. That needs to be -10. Boom, there you go, nice. I actually want to just super quick change the character controller to be like, if that is Q, then up. If that is E, then down. That's better. Right, okay, I can kind of move around a little bit easier now. Nice. Okay, that was easy. That only took 2 hours and a whole lot of modern C++ gubbins. I think I did put the remove back in. Let's just check. Yeah, I did. So that's fine. So I'm actually quite pleased with that. It may not be the most efficient way of doing it, but if we find it's a bottleneck in the future, we can rewrite it. But I kind of like the idea of like, here is your key. It's just a simple number. I don't really care, but all the data is contiguous. Like I quite like using the flat map for that. I think that might be quite nice. I think the next. Let me just start like commenting on this up. Add material manager class. Add material manager to scene. So these are kind of all the same, really, which is render with separate material data and then integrate changes. Yeah, I think the buffer management stuff needs to. I think I'm not going to refactor the buffer management stuff. I think until we've got all the buffers in there that we think we're going to need. So that really is going to be probably the textures. Once we have bindless textures in there, which will be another buffer, then we can take an objective look at what it's like and like refactor it then. I think I'm worried that if I try and refactor it now and then we add another buffer which has a slightly different use case, the abstraction will be wrong. So I'd rather have all the information out in front of me. That's kind of what I really wanted to do today. That's pretty much exactly what I wanted to do today. So I think that was pretty good runnings. Next stream, so Wednesday, the first thing I want to do is integrate ImGUI, because I feel like now that we have, what I really want to be doing for this project is having ImGUI drive as much stuff as possible. So now that we have a model matrix and material data, those should all be driven by ImGUI, and I want that integration first, like, done early. So the first thing we'll do is we'll integrate those. We'll bring in ImGUIsmo or whatever it is, and that way we'll be able to move the cubes around, add new cubes, and then change the colors dynamically. I think like that is quite an important integration to get done. After that, maybe some super basic lighting, just so we can look at something a little bit more interesting. Yeah, I'm sure there's lots of stuff I don't understand. Then maybe basic lighting, and then textures. I suppose we will want basic lighting, so we want to check normal maps. Then we want to have all the different textures that go in there, and then after that will be the deferred renderer, and then we're basically done. I think that's what we want to do. Right, so what stream is this? Stream 6. Well, it's a great new community post. Oh yeah, that's true. Yeah, I was just going to run this off stream because I can't imagine it's that much fun for people to sit. Do people like to watch the build system? I don't know. Yeah, I think that's pretty. It's quite a nice. The abstraction's coming together quite how I hoped it would, which is nice. So I think we're definitely on the right track. It's true. We could chat. Discord, I guess there's a community challenge going on at the moment. If you're new and want to give that a go and write some shader code and have fun over December, like you should come along. That'd be great. Yep, this code is all available as well, open source, which is cool. Once we've done the deferred renderer, then we can do proper model loading, and then we can actually get some assets in there, and then we can build a little level editor. And I bought a modular pack for a level, so we can. I'd quite like it so that we could then like click and drag and make little levels as we go along. I think that might be quite interesting. All the engagement, I do wish. I can't complain because the price is right, but I do wish Azure would build this a little bit faster. Thank you very much. I think maybe 2 shorts out of today's stream, so you know, can't complain. It's about as good as all the others, and they're all terrible. Well, I'm going to assume because this is Microsoft, this is all Azure under the hood. Like, it'd be weird for them to be running this through AWS. I can't remember what it is. I don't have it to hand. I'll dig out the link when we get around to using it. Apologies. It'll be in a tab. It'll be in my email somewhere, and I'm not bringing that up on screen. Surely the correct answer is to build an abstraction, so it doesn't matter whether you're using Azure, Google, or AWS. You can have different backend plugins. I just assumed I was part of the brain rot. Okay, that built and passed, which is sweet. Merge that, confirm that. I'm kind of tempted to never fix the race condition just because it is kind of a fun thing, a fun way to unwind at the end. I think we're good. I think we won the race. I see. There you go. I see they got you doing the important stuff. Okay. So that's bumped that. This is create release, so it means now I should be able to go over to main and check this out, pull this down, get the latest changes. Cool. We don't have to sit and watch the release because it will do a full build again, which does take time. I can't remember if this runs the tests. No, it doesn't. I'm big in myself. I'd say the issue with contributing with open source. So the question is contributing to open source a good way to learn? It is a way to learn. The issue being that obviously you were then having to fit in with the paradigms and the ethos and the workflow of someone else, and it really kind of depends on the amount of time that they can develop to reviewing your stuff. And the open source maintainers are not necessarily there to mentor people. So you might find it a little bit frustrating because you're effectively having to now work with, in addition to learning, you're now having to kind of integrate with more of the human aspect of software engineering, which is a useful skill to learn, but it might not be one that you want to kind of tackle at the same time as learning. You might find there's a small project somewhere that is really accepting and wants contributors, and there's a good community. Like, that's absolutely great. But like, if you are, I'm trying to think of a large OpenGL project that you might come across first. Like, I don't know, maybe like Raylib or something like that. I don't know. It's hard. I would say if you really want to learn OpenGL, the best way is to probably write your own programs first and kind of like go through that. LearnOpenGL.com is great. There's a few other great resources. That would probably be my suggestion over like jumping straight into trying to contribute to open source. But obviously, it really depends on like your skill level and what you're kind of happy doing. It's a third short. I'm nearly as big as that large red cube that dwarfed us for a bit. Okay, built and released. Discord gone out. Do Discord. I will Discord for a bit. I'm gonna have a couple of beers. Great, good stream. Lots done. I'm happy. Thanks everyone for coming along and keeping me company as always. It was great fun, and I will see you all anon.